Hello guys, this is Wits Lounge, Learning Made Easy, and in today's video we are going to be understanding the concept of stoichiometry of particles. Do note, the link to other parts of the study of stoichiometry will be found in the description of this video.
We are going to consider the relationship between number of moles and number of particles. Now, that is represented by a straightforward formula which is expressed as number of moles equals number of particles all over Avogadro's constant. Now, given that Avogadro's constant is equals 6.02 times 10 raised to the power 23 particles, we would find out that if we rewrite the formula, it's going to give us number of moles equals number of particles all over 6.02 times 10 raised to the power 23. So please have this in mind, that the relationship between number of moles and number of particles is expressed by this straightforward formula, giving us number of moles equals number of particles all over 6.02 times 10 raised to the power 23. Now, having established this, the next important point or thing to note is this: the number of particles represented in this particular formula doesn't talk about the atoms necessarily. It majorly describes the molecules. Now, you have understood from the last video that whenever you refer to particles, you're either talking about atoms, you're either talking about molecules, or you're talking about ions. However, in this particular formula, the number of particles that is found with this formula is the number of molecules. So, when I say number of particles, I am invariably trying to say number of molecules. So, if for instance, I am to rewrite the formula, it is now going to be giving us number of moles equals number of particles. This time around, instead of writing particles, I can write molecules divided by 6.02 times 10 raised to the power 23. Now, what if I am asked to find the number of atoms? How do I now find the number of atoms? The number of atoms is found after finding the number of molecules, and it is giving us number of atoms equals number of molecules multiplied by atomicity. Now, we had mentioned earlier on that atomicity is defined as the number of atoms in one molecule of a substance. So please don't get it mixed up. For instance, your gases are usually diatomic, with the exception of your noble gases and ozone. So whenever you see a gas, when you find the number of molecules, you simply multiply by the atomicity, which is 2, and you have your answer for the number of atoms. So anytime you are asked to find the number of atoms, first use this relation to find the number of molecules, and after finding the number of molecules, you now relate the number of molecules to number of atoms by their atomicity. So number of molecules is equals number of atoms is equals number of molecules multiplied by atomicity. With that said, let's try out the question to help us understand this. How many moles of oxygen would contain 1.204 times 10 raised to the power 24 molecules? So to get to solve this, you will notice something. We are asked to find the number of moles, and we are given 1.204 times 10 raised to the power 24 molecules, which refers to a relationship between number of moles and number of particles. In this question, you are asked to find the number of moles when you are given the number of particles. So we have a number of mole to number of particle relation. What is that going to be established as? As earlier said, it is number of moles is equals number of particles. In this case, we said the particles are molecules divided by 6.02 times 10 raised to the power 23. This is a constant, it doesn't change. So in this question, we are asked to find the number of moles. We are given the number of molecules, and the number of molecules in this question is equals 1.204 times 10 raised to the power 24 molecules. So to solve this is quite simple. Sorry, that's a wrong spelling of molecules. So to find the number of moles is going to be given as n equals the number of molecules in this question is 1.204 times 10 raised to the power 24 divided by the constant 6.02 times 10 raised to the power 23. If you do this, you are going to get 2 moles of oxygen. The relationship between number of moles and number of molecules is given as N equals number of molecules divided by 6.02 times 10 to the power 23. Having established that, we are going to be trying one more question to understand this, and that is, what is the number of atoms contained in 0.5 moles of chlorine gas? What is the number of atoms contained in 0.5 moles of chlorine gas? Now, if you remember, we earlier stated when you are asked to find number of atoms is given as number of molecules multiplied by atomicity. Now, we were not given the number of molecules, instead we are given number of moles. So the first thing we need to do is to find the number of molecules using the relation N is equals number of molecules divided by 6.02 times 10 to the power 23. So let's first find the number of molecules. Now, in the question, the number of moles given was 0.5. Please have this in mind. I have said this before in earlier videos. Number of molecules and number of moles are not the same thing. When you are asked to find the number of moles, moles is a quantity, molecule is a particle. Am I communicating? So have that in mind, that the number of moles and number of molecules are not the same thing, because some of you might have actually mixed it up and felt, okay, since they give us number of moles as this, we put it here. That's not how it works. The number of moles is related to the number of particles or number of molecules by this particular relation. So to find the number of molecules, we simply do or make it the subject of formula, and that is number of molecules equals N multiplied by 6.02 times 10 to the power 23. So let's get to that. N in this question is 0.5 multiplied by 6.02 times 10 to the power 23. If you do that, you are going to find out that we are going to have 3.01 times 10 to the power 23 molecules. Now, but in the question, we are asked to find the number of atoms. So let's find the number of atoms. When we have this as our number of molecules, what is going to be the number of atoms in chlorine gas? So we have that the number of atoms is equals number of molecules multiplied by atomicity. And from what we solved earlier on, the number of atoms of chlorine will now be given. The number of molecules of chlorine is 3.01 times 10 to the power 23 multiplied by the atomicity. Every gaseous element is diatomic in nature, with the exception of noble gases and ozone. And because chlorine is a gas, its atomicity is 2. So you have that this is going to be equals 3 times 2, which is going to give us 6.02 times 10 raised to the power 23 atoms. And you have that. Quite simple. Straightforward formulas to solve stoichiometric questions.